Okay, this section is going to be a two-parter. It's about how to add and subtract rational expressions, that is, polynomial fractions. As we know about fractions, what happens is when you're asked to, oh, wait a second. When you're asked to add these together or subtract them or whatever, it's really cool if the denoms are the same, okay? If the denominators are the same, you get to do what they call add like fractions. I heard that from a student and I go, absolutely. The fractions have to be the same kind in order to add them. It doesn't make sense to go, I'll buy half a pie and a third and I'm going to combine that and it makes a what? Well, you have to do the common denominators. So the way it goes, watch how this goes. If you have the same denominator and you're adding or possibly subtracting, you add or subtract that numerator over the common denominator. And the rest is what we talked about before, which is trying to, once you have that done here, you're not done until you simplify and the final answer is done. Okay, so the first video is going to be about adding polynomial expressions that have the same denominator. I think I have one or two examples for you, and then we'll stop, and then we'll talk about what if the denominator is not the same. That means you have to convert them so that, or unsimplify them so that they have the same, and that's coming up next. Okay, so I'm asking you guys to watch these steps. Look, add numerators over the common denominator, and do you remember this from the last video? Factor, cancel, rewrite after that. Okay, so the first part is putting them together, and the rest is what we did in section 1. Okay, so here's what it looks like with a rational expression, okay? And I'm emphasizing it's the same process. So here we go. We got this guy, this first fraction here, adding together, watch the sign, this other fraction, okay? Notice they have the same denominator. Isn't that beautiful? That means, believe it or not, you get to add the numerators, see them? X squared plus 3x over the common denominator, and the rest is factor, cancel, rewrite. Factor, cancel, rewrite. That's how it's done. That's the process. And I know you want to try it, so let's try this one. Oh, that's interesting. Supposed to scroll. I'll let you do it again. Yeah, it's confused. If I do that, does it still do it? Yeah, it's still making it. Okay, so I have to teach it how to scroll. There we go. There's something happening there. Okay. All right. Why don't you guys teach me tech and I'll teach you math. How about that? All right, let's do this one. All right. So, do we have the same denominator? Yes, we do. What do? We add over that common denominator. What do we add? This numerator, which is x squared minus 2, plus 4x minus 19. Seems silly. I know. These are algebra moves that in Algebra 2 we just learned to do. Let's see what we got. We got x squared plus 6x minus 7. Now, before you think I'm going to cancel, remember the story? We got to factor first, then we cancel, then we rewrite. So what do we have? We have x squared minus 2 plus 4x minus 19. You know what? Before I factor the top, I'm going to combine terms. X squared plus 4x minus 21 over x squared plus 6x minus 7. Okay? We did it. That's the first step. That's this step up here where you have got to this stage right now. But to finish, we got a factor, cancel, rewrite. So each one is a trinomial. This is the funnest part if you are good at if you hate factoring, you're not going to like it. I'll just factor it for you. The way it goes, I think by now you should be factoring better. This one is x plus 7 downstairs, and x minus 1, I believe, works. Upstairs, x plus 7, and I think x minus 3. Now I factored that quickly. I'm kind of speeding this thing along. So you can take your time. You could have paused it, go back and factor it yourself, okay? Use the videos as a learning tool. Don't just listen to me. Next time I'll just go, okay, go ahead and factor it, because we're going to do this quite a bit, and then we see how you do. Cancel, my favorite part. Boom, you're gone. Answer, x minus 3 over x minus 1. We don't need the parens anymore. There you go. There's that one. I believe there's one more. Yeah. This is one where we have to worry about subtract. All right, let's write it down. So this is equal to 3k squared. You got to be patient in math too. You got to rewrite 2k squared. When you're on to things, you don't really mind the pain. You're looking to do this right. I'm just rewriting the thing. K squared minus 2k, that's a k, minus 5, and then 2k squared plus 3k minus 5. All right, what are we doing? We're subtracting, which means we need a common denominator, and we have it, 2k squared plus 3k minus 5. It's a blessing when these two match up. That's wonderful. But now this is the weird part. Watch out. We're going to go 3k squared. We're going to add the numerators. That is to say, we're going to subtract the numerator. Have you ever subtracted polynomials before? Let me jump to the side. What we're being asked to do is go 3k squared minus 7k minus 2 and subtract, what was it again? K squared minus 2k minus 5. Do you recall how that's done? That's right. You're going to change the signs in here like we're doing long division, okay? The way it looks like here is you've got 3k squared minus 7k minus 2 minus, and some people will teach it this way, minus parentheses, and you guys might like this better. You distribute the negative, but you got to be careful to watch out about that negative. This is our last example. The video is almost over, so let's take our time and be careful. All right, so we have 2k squared, etc. downstairs. Upstairs, 3k squared minus 7k minus 2. This better be worth it. Oh, you get an A if you do it right. Okay, then. Minus k squared. Minus a minus is plus 2k. Minus a minus is plus 5. And that would have happened here, plus 2k plus 5 minus k squared. See that? So you can go here to the side and do it, or you can do it in the problem itself. And we are ending up with, all right, we can't factor, cancel, rewrite until we factor. So that means we got to throw this stuff together, combine terms, all that wonderful, take out the garbage, do the dishes. We've got 3k squared minus 1k squared is 2k squared. We have minus 7k plus 2 is minus 5k. And then finally we have minus 2 plus 5 is plus 3. We are in a real tussle here, okay? Let's factor these guys. You might have to go over to the side and go, okay, let's do the top. It looks like I'm looking at the factors of 2, 1 times 2, the factors of 3, 1 times 3, or possibly minus 1 times minus 3. And we spaghetti code it to get minus 5, and here it is. Minus 2, minus 3. That's the winner. All right, so let's put that up there. We've got, it looks like we should put in 1 and 2, so k and 2k, and the 2 multiplies with minus 1, so minus 1 here, 1 multiplies with minus 3, and so far so bad, right? The second one, okay, let's see what we get. Put the factors down. They're doing the bottom one now, so 2 is 1 times 2, and minus 5 is actually minus 1 times 5, or 1 times minus 5. And those are the only choices for that, mercifully. And so we're looking for a difference of positive 5. I think I see it right. 5 minus 2. Minus 2 and 5. That's a winner. We did it. So it should be a k and a 2k. And 2 multiplies with negative 1. And k multiplies with 5. Okay. That was a lot of work. What do we do now? The best part. Cancel, rewrite. Cancel, bada bing, I sometimes say. Rewrite answer is 2k minus 3 over 2k. I got too excited. Over 2k plus 5. Winner, winner, chicken dinner. And That is most of what we do here. The next video, when they don't have the same denominator, you adjust them so they do, and then the work is just the same. So that's a lot of work. That's a lot of algebra. I'll see you on the next video.